Okay, this is finding absolute maximums and minimums homework. I'm going to do this as a homework help video. I assigned problems 1, 2, 3, 4, and 9 and 10 the other day. So I'm going to go over problems 1, 3, and 9. Okay, first one, find the absolute maximums and minimums f on given closed intervals and state where these values occur. Okay, so we're going to go do problem 1 here. One thing that we talked about in class is something called a certain test. And it was called a candidate test. And what are the potential candidates? Well, there are two potential candidates for values to consider. And I'm going to put a f of x here on this little table. The first thing we have is the endpoints. And so we know that 0 and 2 are going to be critical evaluative numbers. And f of 0 is quite easy because we can just plug in 0, which is going to be our y-intercept. So our output value is 1. Next, we have, I'm going to try evaluate 2. F of 2 is going to be 4 times 2 squared minus 4 times 2 plus 1. And so 4 times 2 squared, that's going to be 16. 4 times 2 is 8, minus 8 plus 1. 16 minus 8 is 8 plus 1 equals 9. So our output value here is 9. So next, we're going to find the critical numbers. Critical numbers, what do we do to find that? Well, we're going to find the f prime of x, and that's going to be equal to 8x minus 4. And so if we set this equal to 0, and so our critical numbers are where the function is either equal to 0 or undefined. In this case, we don't have an undefined. We say, okay, 8x minus 4. If we solve by factoring, we factor out a 4. So 4 times quantity 2x minus 1. And then we can set 2x and we can divide by 4, right? So that gets rid of that 4. So we have 0 equals 2x minus 1. So we can set 2x minus 1 equal to 0. And then we have, if we add 1, we have 2x equals 1. X is equal to 1/2. And so 1/2 is our other critical candidate. We'll put this. So these 0, 1/2, and 2 are candidates. And what we'll do is we'll substitute in 1/2 for this function up here. So I'm going to put f of 1/2 is equal to 4 times 1/2 squared minus 4 times 1/2, and we have plus 1. And 1/2 squared is 1/4. So 4 times 1/4 is 1 minus 4 over 2 is going to be minus 2 plus 1. So we're going to get 0. So f of 1/2 equals 0. So here is 0. And we say we have, for this one, absolute max of of 9. What did I say? Plus 9. I don't know what I'm doing. Of 9. And where they occur? Where x is equal to 2. So that's one of our answers. And we also have absolute minimum of 0. Of 0, where x equals 1/2. So those would be our answers right here in the center. This kind of cordoning off like this for the answer is. All right. Next, I'm going to go to problem 3. Same type of concept. We have a function, and we're going to make a candidate test. And what are the candidates? Well, we have x, f of x. And our candidates are going to be the endpoints. Again, so we got -1, 4, and then we can say f of -1 is equal to -1 replacing x in the denominator, -1 squared plus 2. So we're going to get -1 over, and in the denominator we have -1 squared is 1 plus 2 is 3. So we're going to get -1/3 as our value. And then we're going to say f of f of 4. Now, one thing I didn't talk about on problem 1 is that we have to have the function has to exist, has to be continuous over this interval. Well, you're not going to have a problem in the numerator and the denominator. Sometimes you could have a problem, except here you don't have any discontinuities based on what's in the denominator, because this denominator of x squared plus 2 has to be a real number. In fact, it has to be positive, I believe, right? Yeah, because this x squared is going to have to be greater than or equal to 0. So anyway, f of 4 is equal to 4 over 4 squared plus 2, which equals 4 over 4 squared is 16 plus 2 is 18. So that's going to be 2/9. Right? That simplifies to 2/9. So 2/9. And now for the candidates, we're going to set these equal to 0. And now we have I'm going to use this as take the first derivative. We're going to call this a quotient of two functions. We use the quotient rule. So we're going to say the high is equal to x. The derivative of high is equal to 1. The low is equal to x squared plus 2. And the derivative of the low is equal to 2x. So over here, I'm going to put f prime of x is equal to low d high. Well, low is going to be x squared plus 2. D high is 1 minus high, which is x, and d low is 2x. And we're going to have this all over low squared, which is going to be quantity x squared plus 2 squared. So simplifying on our numerator, we have x squared, and then 2 times 1 is going to be plus 2. and then we're going to have minus 2x squared, and it's going to be over rho squared x squared plus 2 squared. And then just simplifying, we have x squared minus 2x squared. We're going to have negative x squared plus 2 over quantity x squared plus 2 squared. That's going to be f prime of x. And if we set this equal to 0, well, we say 0, and we just, it'll be 0 where the numerator is 0. So 0 equals negative x squared plus 2. And we can solve using square root method on this one, since we don't have any x term. So we're going to have if we add x squared to both sides, we'll have x squared is equal to 2. And then taking the square root of both sides, x is going to be equal to plus or minus square root of 2. And between negative 1 and 4, that's going to be negative square root of 2, that's like negative 1.4. So square root of 2 is going to be our other critical number. And so if we plug in this one here, f of square root of 2 is equal to square root of 2 is for x. And in the denominator, we get square root of 2 squared plus 1. And then, so we're going to get square root of 2 over square root of 2 plus 1. That's going to be square root of 2 squared is 2 plus 1 is 3. So we get square root of 2 over 3. Well, we know our minimum is going to be this thing right here, right? It's going to be negative 1/3. So we say we have absolute minimum of negative 1/3, where x equals negative 1. So now for our maximum, we have to look at what is square root of 2 over 3? Well, square root of 2 is about 1.4, and 1.4 divided by 3, that's going to be just a little less than 1/2. Is that right? And a little less than 1/2 is going to be bigger than 2/9. So we're going to have absolute maximum of square root of 2 over 3, where x equals square root of 2. Okay, so that's going to be number 3. For number 4, just take a look at the same thing we've been doing. I think you have to use your chain rule on this one. And the last ones we have here in the assignments, the assignment given is 9 and 10. Now, if you look at 5 and 6, 6 is a trigonometric function. We haven't gone over trigonometry very much yet, trigonometric differentiation. 7 is a trigonometric function. 8 is an absolute value function. Anyway, here we are at 9 and 10, and I'm going to go over 9 here. What is the smallest possible slope to y equals x cubed minus 3x squared plus 5x minus 1? Well, you're going to have smallest slope. Let's take a look at this. The smallest slope is going to be the most negative number, or 0 if it's not a negative number. So let's go ahead and take the first derivative of this. Y prime is equal to 3 x squared minus 6x plus 5. And then to minimize that, this is going to be the lowest number here. And so we're going to be looking at, you're going to be looking like, when you graph it, be looking something like this. I think it's going to be over on the right side. It looks something like this, probably. Well, how do we find where that minimum occurs? We got to find the double prime is equal to 6x minus 6. And now if we set this equal to 0, we got 0 is equal to, just factoring out the 6 times quantity x minus 1. So we have 0 equals x minus 1. So we have x equals 1. So our smallest possible slope is going to occur where x equals 1. And what is that smallest possible slope? We got to have y prime of 1. So we say y prime of 1 is equal to 3 times 1 squared minus 6 times 1 plus 5. So for that, we're going to get 3 minus 6, which is negative 3 plus 5, which equals 2. So y prime of 1 is equal to 2. So the smallest possible slope is equals 2, and it's where x equals 1. So, that's it. And then 10, you're going to have to look at position here, and then you have to find velocity and acceleration. So do your best on number 10 and see what you come up with. Good luck on all these, and thanks for viewing.